What's up guys, and welcome to this video about building a clean architecture MVVM Android application. In our example here we will build an order application which contains multiple orders like we can see here on this starting page, and when we click on an order then we can see the different items which belong to this order and also get the total amount at the bottom. We can also create then new orders by clicking on this plus floating action button. Then we get a list of deliverers. We can also search for a deliverer, for example, the school stuff provider here. When we click on this deliverer, we get to a section where we can select different products. Like here with the pencil, we can click on plus for 3 pencils here. Then we also need a pencil case, for example, and a school bag. And then we can click on this floating action button at the bottom right and get a checkout overview which contains all the items we selected, and we can then confirm this order, and then you can see at the top we have this new order here from our school stuff provider. Let's also check if the school stuff provider order contains all the items we have selected. We have 1 pencil case, 3 pencils and 1 school bag, so everything works fine here. And I've chosen this example for building a MVVM Clean Architecture application because it is not that easy. It requires a lot of data logic, a lot of state management logic, because we have different orders which can contain different products. Then a product can belong to different orders. We have also deliverers which has multiple products, and also a deliverer belongs to a specific order. And you will see this is not that easy, but I think such a little bit more complex example will be more realistic to the real world. And I think you can learn a lot of stuff here when we build this, and we will build this strictly conforming to the clean architecture principles. And one thing I would like to mention before we actually start is that we will structure this project as if this would be a multi-module project. We will have an order module later and a core module. Let's take an example of a tab application where you have 4 different tabs, and the first tab would be our order module. The second tab, for example, a deliverer and products module where you can define deliverers and products. And the third tab would be a settings tab or user profile or something like this, and so on. So you can imagine that this order application here could be also one tab of a bigger application, one module of a bigger application. And we will also have a core module here, but in the example of the tab application, this core module could be also used from different or from other tabs, and not only from the order tab. But of course we need to access the core module from our order module in order to make this work properly. This is why we define the core module here as well. Alright, okay, enough talking. Now let's actually start building the application. First of all, I would like to go over the dependencies we need. For example, room database, Dagger, Hilt and compose navigation. Let's go to our build.cradle on the root level, so on the project level. Here we need the Dagger Hilt dependency and also the Dagger Hilt plugin, because as I already said, we use Dagger Hilt for dependency injection later. And then in our build.cradle for the module, we also need the Kotlin Cap plugin and the Dagger Hilt plugin as well. And down here in the dependencies section, we need navigation for compose navigation. I'm not quite sure if we actually need this icons dependency here, but just leave it like this. And the dependency injection, Dagger Hilt dependency on the module level, and of course room database dependencies. I will provide this initial setup in my GitHub repository, which is linked down below, and of course later when we have finished the application, also the finished state of the application. Alright, okay, I would like to define the 2 packages for our modules first, so that you get a slight overview and keep track on which module we are currently in. Let's create a package called core. This will be our core module, and also a package for our order feature. After that, I would like to define the room database and all the different entities. And the room database will belong to the core module, because let's imagine that we not only have our order feature, but also a deliverer feature or some kind of other feature, and it also needs to access to the database. Then this wouldn't make sense to define the database inside our order feature. We will do this in the core feature because everyone needs to access the database. In here, we will have a data layer and a local package where we can put the local database logic into. In this local package, we will have another package for our different entities, and we will start with the deliverer entity, which will be a data class. Deliverer entity, and yes, okay. In order to make room aware that this is an entity for the database, we need to annotate this with @entity. And in here, we will have a primary key so that the deliverer entity can be identified, deliverer ID of type string, and we will also have val name. After that, we can create the product entity as well, which will be also a data class, product entity. This will be also annotated with @entity, has also a primary key, val product ID of type string, and then a value name of type string, val price per amount of type float. So each product has a specific price per amount. And it has an additional property belongs to deliverer, because each deliverer can have multiple products, but each product only belongs to one specific deliverer. This is a relation in our database. And now things will get a little bit tricky because Room is really a pain when it comes to modeling and defining relational database. But well, Room uses SQLite, so this could be implemented a little bit better in my opinion, but maybe in the future. Let's go to our entities package and create kind of a relational data class which combines this relationship. We will call this deliverer with products data object, which will be also a data class. And this data class has an embedded annotation, val deliverer entity. So this will contain our deliverer entity. And also we will annotate this with @relational. Let's not forget the comma here. Then we can import the relational. And we have the parent column, which will be our deliverer ID, and the entity column, which will be our belongs to deliverer. And then we can define val products of type list of type product entity. Okay, let's go through this again. We have our deliverer entity, so each deliverer can have multiple products. And which products are in this deliverer with product data object is defined here. The parent will be our deliverer entity, so the deliverer ID, which is unique. And each product will have a belongs to deliverer property, and this belongs to deliverer property will be the different deliverer IDs. So each product has an additional field, an additional property which says that it belongs to this specific deliverer ID. And so this can be calculated. We could have also used a type converter for our deliverer entity to convert the products to a long string JSON, and the deliverer entity would then have an additional field called products. And after we retrieve them, we can convert it back to objects. But I think if we have like 200 products for each deliverer, then this is not really clean. And we are also dealing with a relational database here. So please don't use type converters for such a thing. This is no SQL stuff, and we are dealing with relational data. So let's create another entity class, order entity, and this will be also annotated with @entity. Of course, also has a primary key, order ID of type string, val date of type string when the order was actually triggered, val deliverer time. Maybe you wanna say the deliverer, I want to get this order in 2 months or as fast as possible. Then a deliverer name. Normally we would also apply val belongs to deliverer field here, and then we would have the same principle like we have for the product and the deliverer. But right now we are only interested in the deliverer name for each order for the sake of simplicity. We need to create another entity as an associated entity between our order and our product entity. This is a many-to-many relationship, which means that each order can contain multiple products, and each product can belong to multiple orders. And to specify, to model this the right way, we need this associated entity. And we will call this order product entity, and this will have an entity annotation as well, but this time we will have primary keys, which will be an array. We will have the order ID and the product ID. We also need to make this a data class, and the values will be order ID of type string, product ID of type string, and we have an additional property here, which is the amount. Now with this primary keys, it gets unique again. Each order alone wouldn't be unique because it could have multiple products. And each product wouldn't also be unique because it could belong to different orders. But together they are unique again. And we also have an additional property which says then that in this specific order and this specific product, we have chosen this specific amount. The last data class we need is kind of the same like we had with our deliverer with products data object here. We also need to combine the different entities to an order object, to an order entity later, which we can then retrieve in our repositories. Let's create a new data class. This will be order with product data. So let's call it order with products data object. This won't have any annotation above, but it has this embedded annotation, the first property, well order entity, like this. Then we again have the relation annotation. For the parent column, we have the order ID. For the entity column, we have the product ID. And in this case, we also have an associated class. So we can say associated by junction order product entity, which is our associated class, double colon class. And for the property itself, we can say, well, products list of product entity, like this. But we also need the amount of each order product combination. And now things will get a little bit dumb in my opinion, because this is not supported that well when it comes to associated class with additional properties in Room. Maybe they will do this better in the future, but right now we need to solve this like this. We will have an additional relation annotation. For the parent column, we will pass order ID, and for the entity column, we will pass order ID as well. And then we can define the order product entities property of type list of type order product entity. And this will give us the same list size here like we have in this product section, so we can map them together later. But this is not that clean, but it's the only way I found. Okay, this was the difficult part, setting up all the different entities. Now we can define the database itself, and Room will do the rest for us behind the scenes. In our local package, we will create a class order database. And I think we can also zoom in a little bit so that you can read this better. We will annotate this with @database. The entities will be an array of our defined entities. Deliverer entity, double colon class, order entity, order product entity, and product entity, like this. Let's also format this a little bit. For the version, we will pass 1, and then Room knows which entities we need, which entity classes it should define. The order database itself will be an abstract class which inherits from Room database. And in here we can then define abstract functions which will return our DAO objects later. But first we need to define them. In our local package we will define the different DAO interfaces. We will start with the deliverer DAO. We need to annotate this with @DAO for Room to know that all the deliverer operations on the database are defined inside this interface. We will have an insert operation. The on-conflict strategy will be replace. The function will be a suspend function, insert deliverer, and this takes a deliverer entity. Then we will also have a transaction here. I explain why we need this after we define this. A query, and we will select all from deliverer entity, and not this, like this. And this will be a suspend function as well, get deliverers, and this will return a list of deliverer with products data object. The reason why we need this add transaction annotation is because this deliverable with products data object contains different or multiple entities. If we have a closer look at this data class, it contains the deliverable entity and also a list of product entities. So in the background, it needs to do two queries to map them together inside this data class. And this transaction annotation means that the operation will be atomeric. So it will only return this list if all the subqueries were actually successful. We will have one additional operation which selects a deliverer name by its ID. We will need this query at one specific point later. Let's define it here. Select name from deliverer entity where the deliverer ID is equal to the past deliverer ID. And in here we can define the function get deliverer name by ID, deliverer ID of type string, and this will also of course returns a string. Then we will also have an order DAO in our local package, which will be also an interface. Don't forget the add DAO annotation. Here we have a transaction as well, add query, select from order entity. So get all orders, which will be a suspend function, get order with products, and this will return a list of order with products data object like this, because this is also a combined return type. So we need this add transaction again. Then we have an insert operation. The onConflict strategy will be onConflictStrategy.replace, suspend function insert order. This will take an order entity. The last operation we need to define is also an insert operation onConflictStrategy.replace again, suspend function insert order product entities. This will be our associated class. We also need to insert this, of course, to have the different orders with different product amounts and all that stuff. This will be order product entities and takes a list of order product entity. And after that, we can go to our local package again and create another interface, which will be our product DAO. Add DAO annotation. For this interface, we only need to define two operations. The first will be an insert operation onConflictStrategy.replace again, suspend function insert product, and this will take a product entity like this. And after that, we also have a query. Select, let's import this from product entity where belongs to deliverer is equal to deliverer ID. So we can get specific products for a deliverer. Later, when we want to see all the products a deliverer offers, we want to list them, then we can use this query. This will be a suspend function as well. Get products for deliverer. It takes the deliverer ID of type string and returns a list of product entity. All right, okay, then we can go to our order database and define the different functions. Abstract func order DAO will return order DAO. Abstract func product DAO, which will return the product DAO, and abstract func deliverer DAO, which will return the deliverer DAO. All right, okay, this was it for the database setup. I know a lot of stuff, especially with these relationships, but in a real-world application, you also have this kind of relationships in your data model. So I think this is fine here. Let's go to our core module package. And in here, we will create another package called DI for dependency injection, because now we will start to set up Dagger Hilt. And after this is set up, we can finally start with different data, business logic, view models, and all that kind of stuff. But first, we need to make dependency injection possible so that we can inject our dependencies inside our view models, for example, or inside our use cases. For that, we will create an object. This will be called app module. In order to make Dagger Hilt be aware of our app module, we need to annotate this with add module and add install in. And we use singleton component double colon class here because we will provide the dependencies as singletons. In here, we can then say add provides, add singleton, and we will first provide our order database. For that, we need the application context, which can be provided by default from Dagger Hilt. We don't need to define this. and this will return the order database. And in here we can say return room.databaseBuilder. We will pass the context, our order database class.java, and the name for the database, which we will simply take order.db for. And then we can say .build, and Dagger Hilt now knows how to create such an order database. Then we also want to provide the order DAO, which we can annotate with @provides again, @singleton, function provide order DAO. This will take the order database, and since Dagger Hilt now knows how to provide this order database, this can be used in here to provide the order DAO. And it will return an order DAO. And we can say return order database.order DAO. And the same thing for our deliverer DAO. We can, I think, simply copy and paste this here and rename this provide deliverer DAO. This will also take the order database, returns a deliverer DAO, and for here we say .deliverer DAO. And one more time for our products DAO. Provide product DAO. This will return the product DAO, and down here order database.product DAO. Alright, okay, I think this is a good point to build the project the first time. I already did this, my build was successful. If you are followed along until now, then I would suggest you to also build the project to check if everything works properly. I think we should finish the core module first before we go to our order feature module, because there's not so much left. We only need to define a little bit of domain models and the navigation, and after that we can go to our order feature module and can then use the core module. If we wouldn't finish the core module first, we would later need to switch between the two modules, which might be a little bit confusing. In our core module package, we will create another package called domain. In the domain package, we will create another package called model, where we put in our business logic models which belong to the core module. And this is on the one hand our deliverer, which will be a data class, and on the other hand we will have the product. The reason why they are in the core module and not in the order feature module, for example, is because in the order feature we need access to the deliverers. We need to access the deliverer list so that we can list the different deliverers where the user can select one to select the deliverer's products. So also the products are accessed in the order feature. And now let's imagine we have another feature called deliverer feature, and there you can define different deliverers, different products. Then you would also need the deliverer and the products there, because they can be accessed from different points in our application. Let's define our deliverer data class, val deliverer ID of type string, val name of type string, and val products of type list of type product. Then for our product data class, we will have a product ID of type string, val name of type string, and val price per amount of type float. After that, we can set up our navigation logic. We will create a package called presentation inside our core module, and we will create a composable file called navigation. This will be a composable navigation. In here we will have a val nav controller is equal to remember nav controller. And also the reason why we put this navigation component inside our core module is because later we could have more modules which also need to access the navigation. And so the navigation belongs to the core module. We will have a nav host which takes the nav controller. And let's import this nav host. And then we can open this, and we also need to define a start destination. But for that we first need to define our different screens. We can make this a sealed class called screen routes, and this takes a val route of type string, and in here we will have the different screens defined as objects. The first screen will be our order screen, inherits from screen routes, and the name will be order screen. Then we have order choose deliverer screen, where the different deliverers are listed and the user can choose one. Screen routes, and we will name this order choose deliverer screen like this. And after that we need one more screen, the order choose products screen, where the deliverer is selected and then all the corresponding products are listed and the user can define how much he wants to buy. also inherits from screen routes, and for the name we will say order choose products screen. After that we can define our start destination, which will be screen routes dot order screen dot route, because the first screen we want to show is the order screen. Then we need to define the different composables which should be used for our screens. This will be composable. The route will be screen routes dot order screen dot route, and we didn't define the order screen yet, but just let it write like this: order screen. This takes the nav controller, which will be equal to nav controller. Before we start with our order screen and the corresponding view model, I would like to add another package inside our core module called util. And in this util package, we will create then an object called dummy data, because we somehow need to get access to different deliverers with different products. The application does not have deliverer feature or product features or something like this. So we need to insert them manually once so that we can work with this data and define our different orders. This would be just too big for this application. This would be then a 5 hours video if we would also have a deliverer feature. So let's just define some dummy data here. Let's import deliverer and also product. And then we can insert some example deliverers and products, which we can then use later in our order feature. But we already defined all the necessary logic to insert deliverers and products. So we can make use of this. And you could also expand this example application with more features, with a deliverer feature, where you can also make the user define different deliverers with different products. But right now we will only focus on the order feature, and for the deliverer and products we use this example data. Of course, you don't need to type this off. You can just check out my GitHub's repository, which is linked down below, and copy and paste this dummy data. Alright, okay, let's go to our order feature module and create another package called presentation. In this presentation package, we will first define our order screen to get rid of this compiler error inside our navigation component. Order screen, which will be a file, composable, and this will be called order screen and takes a nav controller of type nav controller. And then after the import, the arrow should be gone. Now we can go to our main activity, remove the default stuff, also this one, and invoke the navigation composable. And let's start the application the first time to see if we are currently able to launch this without any errors. Okay, cool, we don't get any errors, but we need to annotate this main activity with Android entry point for Dagger Hilt, because if we would use inject annotations for dependency injection later, then this wouldn't work with this annotation missing. Let's also quickly create the Dagger Hilt application file, which is also required in a Hilt application. This will be a Kotlin class called order app, for example, inherits from application, and we annotate this with @Hilt Android app. And the last thing in our manifest, we need to define this application file like this, and then the Dagger Hilt setup is finally finished. Now let's go back to our order screen and create the corresponding order view model. In our presentation package inside the order module, we will create another Kotlin class called order view model. And this class will be a Hilt view model, and we can then inject via constructor different dependencies. Because we set up Dagger Hilt properly, this allows us to inject all the dependencies we need now in our view model in a very easy and convenient way. We can annotate this with @inject constructor, but right now we don't have any dependencies defined yet, which we need in our order view model. Later we will have an order repository, which gets injected here. So let's first define different state vars and all that kind of stuff we need in such a view model. We will have a private late init var orders of type list of type order. And now we need to define this order data class, which is also business logic, which are our orders from the business logic. So in our order feature, let's create a new package called domain and also a package model. In this model, we will then define this order data class, order like this. Such an order has an order ID of type string, date of type string, when the order was confirmed, val deliverer time, when the order should be delivered, val deliverer name of type string, and val products of type list of type product, like this. And the reason why the order domain model is now in the order feature is because I don't have a use case in my mind where the order should actually be used on another place in the application. Such an order is only used inside our order feature, and deliverers and products, which are defined in our core module, can be used on different places in the application, in my opinion. Maybe you have another use case where this order could be also accessed from another point in the application, and then this order could be also defined inside the core module. Back in our order view model, we can then import this order from our domain. And the reason why this isn't a state and just a list, a normal variable, is because this will be our single source of truth. For the state, we will define additional objects because inside this order, there are also a lot of products, for example, and we don't want to have these products in our state. For that, we go to our presentation package, create a new package called state. In the state package, we will create a data class called order list item, and this will represent one item in the order list the user can see at the order overview. And this will have different properties than a domain order object. So we should use a state class, a separate state class, which contains exactly this information which we are actually need for such an order list item. And this will be a data class, as I already said. It has val order ID of type string, val deliverer name of type string, and also a total amount of type double, because for each order we want to show at the compact overview the total amount and the order date of type string. Then back in our order view model, we will define the order list state. Var order list by mutable state of, and this will be of type list, of type order list item, and will be an empty list by default, because by default we need to fetch the orders first, and then we need to map these orders we get from the repository to such an order list. And this is why the list is empty by default and gets initialized after this. This will be also a private set, because this should be only modified inside our view model. And then we have also a state var is order dialog shown, because when we click on an order, we want to see the detailed view. So which products were actually bought in this order, and also some additional information, for example. By mutable state of false, because by default we didn't select an order, the user needs to press on an order, and this is why this is set to false by default. The last state var we have here is var clicked order item. In case the user clicks on an order item, we also need to initialize this state var to actually show the corresponding order products and the total amount, the different products amount, and all the stuff. This will be mutable state of order detail list item, which we didn't define yet. And this is of type optional, because by default there is no selected order item. Let's also make this a private set. And in our state package, we will create another data class called order detail list item. And this will take an order ID of type string, val deliverer name of type string, val order date, and val products of type list, of type product list item. And we also need to define this product list item. I know these are a lot of data class definitions here for the state, but in order to make this clean, this is absolutely necessary, because if your application grows and you just use one state data class to represent your state, what the user should see, then this can be really messed up if your application grows and you didn't structure this the right way. Then you always need to add additional properties if you want to add a new feature. And if you define this data classes for the state exactly like the user actually sees the different properties, then this is highly adaptive. Because if you say, I also want to show the order's email address here, then you can just add another value below this order ID, for example, and then you have also an email address. And if you just would use one data class, then you would blow this up, and this data class would just grow and would be too big to manage anymore later on. Let's create the product list item in our state package as a data class. product list item, which will be a data class, of course, val ID of type string, val name of type string. This product list item has also a price per amount of type float, val selected amount, so how much of this product was selected, of type int. We will also have a val is expanded of type bool. We actually don't need this here in our order overview, but we can use this product list item later when the user can select different products and select the amount of the different products for a specific order. And for that, we can use this product list item data class. Maybe we should have also defined a new data class for that, but I think this is fine now. Otherwise, this would be a little bit too big of defining different data classes. All right, okay, back in our order view model, we can then import this order detail list item and the error is gone. When this view model is created, we will initialize the different orders. We can do this in this init block and then view model scope dot launch. Okay, we don't have access because it needs to inherit from view model. And then we get access to the view model scope. And in here we can launch the repository request to get the different orders from the database. And let's leave this empty for now because we didn't define the order repository, but we will initialize the orders in here. And then we have an additional function on order click. So if the user clicks on a specific order, then we get the order ID of type string. And we can init the order for dialog and pass the order ID. We will define this function soon, and we say then is order dialog shown to true. The init order for dialog function will be a private function, init order for dialog, and it takes the order ID of type string. And now we need to get the order which was actually clicked from the user. We can say clicked order item is equal to orders first or null, and we compare the order ID of the current order inside this orders array to the clicked order ID. And then this will return an order. And right now we will get an order back, but we want to have an order detail list item. And we need to define a specific mapper function now to map such an order to an order detail list item. We can do this in our presentation package. There we create another package called mapper. And we will do this in the presentation layer because we want to extend the order now, the order data class, to make this mappable to such an order list item. And if we would use this in here, for example, we say something like this, function to order detail list item, and we would return an order detail list item, then you can see with this import instruction that we are currently accessing the presentation layer. But we are in the domain layer, and in terms of clean architecture, we aren't allowed to do this. And this is why we define this mapper inside this presentation layer as an extension function. Let's remove this again, also remove this import. Inside this mapper, we will say Kotlin file order mapper, and we will make this an extension function. So fun order to order detail list item returns an order detail list item. And let's import this order now. And you can see with the import instruction that we are now accessing the domain layer from our presentation layer. But this is fine. In clean architecture, we are allowed to access the domain layer from our presentation layer, but not the other way around. And this is why we make this a mapper function inside the presentation layer. In here, we can say return order detail list item. For the order ID, we will pass the order ID. For the deliverer name, the deliverer name. And in such an extension function, we of course have all the access to the orders property. The order date will be date. And now we also need to insert the products. We need a product list item here. But right now, if we have a look at the products, we will have a list of products. So we also need to make a mapper function for the domain product to a product list item in the presentation layer. And I also need to make a little adjustment in our order domain model class. We don't have products here. We have bought products because each order has, of course, bought products and not general products. And for that, in our model class, we also can define this bought product domain model, bought products. This data class will have a product ID of type string, a name of type string, price per amount of type float, and an amount of type int. And then in our order domain model, we have a list of bought products. Okay, all right, let's go back to our order mapper. Here we had the problem that these products, now they are bought products, don't match with these products which are of type product list item. So we need another extension function inside this mapper package. Let's create a Kotlin file called product mapper. And this time we want to map a bought product to a product list item. So function bought products to product list item. And the same principle here. We're accessing the domain layer because we need this bought product which sits in the domain layer, but this is fine since we are in the presentation layer. And this will return a product list item, return product list item. The ID will be product ID, name will be name, price per amount will be price per amount, selected amount will be the amount, and is expanded is not needed here, so we can just set this to false. Inside the order mapper, we can now map all these products, products.map. We get the bought product here, and we can simply say bought product to product list item. All right, okay, now we have done all this work, all this mapping to simply say dot to order detail list item like this. And you can see we can make this view model very clean with this approach because all the mapping stuff runs behind the scenes in other classes which are responsible only for mapping stuff, and we don't need to do this inside our view model. The next function in our view model will be on dismiss order dialog. So when the user dismisses the detail dialog and goes back to the order overview, then we simply say is order dialog shown to false. We can also set the clicked order item to null again. The last function we need in our order view model will be a private function called setup order list. In here we will set up and initialize our order list from the orders which we get from the repository. We will first need a formatter for the date time formatting because we want to sort the different orders by date, and in the database the date is only saved as a string, so we first need to convert this string to a date to make the comparison possible. Date time formatter dot off pattern, and I will use this pattern day dot month year, the hours, the minutes, and the seconds, because I will also save the date later in this format. Date sorting could be also done in a use case, but I'm not that big fan of using use cases when there are just 2 lines of functionality. We will also apply use cases later. We have 3 use case classes in this project to also show you how and where to apply use cases, but we won't use a use case for this sorting. Before we actually come to the sorting, we need another extension mapping function because we also want to map an order to order list item, not the order detail list item, but the order list item in this case. We will return order list item. The order ID will be order ID. The deliverer name will be deliverer name. The order date will be date. And we also need the total amount. For that we make a little calculation, products.sum of, and here we say it.amount multiplied with it.price per amount. Then we will convert this to double and the compiler error is gone. Back in our order view model, we can then start with the mapping of the initial orders to our order list items. Our order list is equal to orders.map. Here we get the order. Then we say order.toOrder list item, and we will also sort this by descending because we want to have the latest order at the top. Here we also get access to each order list item. Here we say local date time dot parse. We pass order list item dot order date and our formatter. And then this initialize our order list with all the orders we get from the database, from our repository, and sorts it by the date. Up here in our init block, we will get the orders from the order repository here, and after that we can say set up order list, because then the orders are here inside the orders because we are in the coroutine scope. The repository function will be a suspend function, so this will suspend until the orders is initialized, and then we can set up the order list. Okay, alright, I think it's time to implement this repository so that we can finish this view model. We will define the repository's interface inside the domain package, because then our view model does not directly access the data layer. It only accesses the domain layer, and the realization of this interface of the order repository will then be happen inside the data layer. So again, the data layer accesses the domain layer, and we have all dependencies in the right direction. We will create a package inside the domain package called repository. Inside this repository package, we will create our interface called order repository. This repository will have 5 suspend functions. The first will be insert order, which takes an order. The second one will be suspend function get orders, which will return a list of order. The third one, get deliverers, will return a list of deliverer. And the fourth one, get products for deliverer, takes a deliverer ID of type string and returns a list of products. Then the last one will be also, of course, a suspend function, get deliverer name by ID, also takes a deliverer ID of type string and returns a string, which will be then the corresponding name. And although we are inside the order feature, our order module, we can access this deliverer, and we have also the deliverer logic to get deliverers, to get products, because we need this in our order feature, and this belongs to our order feature, even though we need to access the deliverer DAO and the product DAO later. But this is absolutely right to have this logic inside our order feature, and therefore we have created this core module where the deliverer and product logic for data accessing is actually defined. Okay, alright, let's implement this repository's interface definition. In our order feature, we will create a new package called data and another package called repository. In this repository, we then create a Kotlin class called order repository implement, and this will get some injected constructor arguments, and this will be val order DAO of type order DAO, our deliverer DAO, and our product DAO. And of course, it realizes the order repository. We can implement all the member functions then, like this, and we first start with the insert order function. For that, we can say order DAO dot insert order, and now we need to map our order to an order entity. And we have the same principle here now for order to order entity, like we had on the UI, where we mapped the order to an order list item, for example. In our data package, we create another package called mapper. And we again do this in the data layer because we need to access the domain layer where our order is actually defined. If we would define this mapping inside the domain layer, then we would need access to the order entity, which is defined in the data layer. And this is why we again do this not in the domain layer, but in the data layer. We will create a Kotlin file called order mapper. In here, we will again create an extension function, fun order to order entity, and this will also take a deliverer name of type string and returns an order entity like this. Let's import this order from the domain module or from the domain layer. Return order entity. For the order ID, we will pass the order ID, date will be date, deliverable time will be deliverable time, and deliverer name will be equal to the deliverer name. Now we can go back to our order repository implement and can say order.toOrderEntity. And for the deliverer name, we simply pass order.delivererName. After that, we also need to create the list of the associated class, so the many-to-many relationship associated class between our products and our order. We will say val order product entities is equal to order.products.map. In here we get access to all the bought products, and we can say order product entity. This is our associated entity. Order.order_id. It also takes the product ID, which we will get from the bought product.product ID and bought product.amount. After that, we can say order_DAO.insert order product entities, and we pass our order product entities, and then they are also saved in the database. Before we start with the next repository function, we will create another mapper function, which will be our order with products data object mapper. We will call this order with products data object mapper like this. And this won't be a class, this will be a file, and we will define an extension function, order with products data object, and this will be a mapper function to an order. This will return an order, of course. Let's import order from our domain layer. Return order. For the order ID, we will pass order entity dot order ID, because this order with product data object contains an order entity. We can have a look at this. An order entity here, a product entity, and also the associated class order product entities. And we need to kind of map them together to such an order in this mapping function. For the date, we will say order entity.date. The deliverer name will be order entity.deliverer name. The deliverer time, order entity.deliverer time. And after that, we also need to define or map the products. When we have a look at our order with products data object again, then we need to know that these two lists kind of belong to each other. We will have two equal sized lists with the product entities and the corresponding order product entity, so we can make use of this. We will say products is equal to our products.zip, and we will zip this with order product entities so that we get a pair here which belongs to each other. And then we will say map, and we get a pair, as I already said. And down here we can map this to a bought product. And we will say pair.component number 1.product ID, pair.component number 1.name, pair.component number 1, come on compiler, price per amount, and pair.component number 2.amount, like this. Back in our order repository implement, we can then simply say return order_DAO.getOrderWithProducts.map it.toOrder. And now you can see again the huge advantage of this mapper classes, because this code is so clean and so easy to read. But yes, of course, you have a lot of objects, and you also always need to define these mapping functions. And I hope this does not get boring for you, but yeah, this is my style when it comes to programming, and I have a lot of good experiences with it. And I think it also sticks very well, or it's really cool to combine this with clean architecture principles. Then you have a really, really clean code structure. All right, okay, the next function will be our get deliverers. Here we can say return deliverer DAO. We actually don't need this get deliverers function yet because we are still defining our order view model. But I think let's just finish this repository here. In order to make this function work properly, we need two additional mappers, but I think these are the last ones then. We have one mapper for products and one mapper for deliverers. And we will do this in the core module because deliverer and product stuff belongs to the core module. Let's actually create a package inside the data package called mapper. Inside this package, we will create a Kotlin file called deliverer mapper. We will extend the deliverer entity and will define the mapping function to deliverer. And here we will pass products, a list of product, and this will return a deliverer. And then we can say return deliverer. Deliverer ID will be deliverer ID, name will be name, and the products will be our products. And after that, we also define another file, product mapper, like this. We will extend the product entity, and the functioner will map a product entity to a product. So it returns the products, and in here we can return a product. For the product ID, we will pass the product ID, the name will be name, and the price per amount will be price per amount. Okay, all right, let's go back to our order repository. Here we can say deliverer.getDeliverers.map, and we will access it with it. You can also name this with this long name, but I think it is fine here. It.deliverer entity .toDeliverer, and we also need to pass products here, and for that we can say it.products.map, and in here we get access to the product entity, and we will map the product entity to products, and then this again looks very clean and very few lines are needed to make this work properly because of our mapper functions. Down here for the get products for deliverer, we can say return product.getProducts for deliverer, and we pass the deliverer ID, and we will map this deliverer. What do we get here? Product entity, and we will say product entity.toProducts. For the get deliverer by name, we simply return deliverer.getDeliverer by name, and we will pass this deliverer ID we get passed into. All right, okay, let's close all these different folders and packages and go to our presentation package inside our order module, and then we can go to the order view model and finish the order setup. We will say orders is equal to, we first need to inject, of course, our order repository, and we will make this a private val. And down here we can then say order repository dot get orders. Okay, all right, let's go to our order screen. It's time to get also a little bit of a visual feedback. Here we need the order view model, of course, which we can get from Hilt view model. In the order screen, we need a scaffold state because we also have a floating action button and a top bar. We can get the scaffold state from remember scaffold state. Then we have a scaffold which takes the scaffold state, and it also takes a floating action button which can be defined in this block. Floating action button like this. We have an on-click method which we will define later, and we also have a background color which we will set to orange. And I also forgot to add the different colors. Let me quickly do this. In this UI package, in the color section, we will simply add these 3 colors. They are enough here, I think. You can also choose your own colors or simply copy and paste them. Back in our order screen, we can import the orange color. It will simply contain an icon with an image vector. Let's import icon. The image vector will be icons.default.add. And we also have a content description, floating action button, add order. And the tint of this icon will be white. We will also have the top bar, which we can define in this block. This will be a top F bar. And we don't need this row scope. We only need the constructor. Here we pass the title. The text will be order overview. The color of this text will be white, and we also set the background color of this top bar to orange, and then we can open the scaffold scope. First of all, let's check if the order view model.orderList is empty, because then we don't have any order list items to show, and we can show the user a message or text that there are currently no orders. This will be a box modifier. Let's import box first. The modifier will fill the max size. The content alignment will be alignment.center. Then we can open the box scope and we simply say there are no orders yet. In the else case, if there are currently orders to show, we will have a lazy column. This takes a modifier which will fill the max size. The background will be gray. The padding will be 10 dp. And we also have a vertical arrangement by 10 arrangement.spaced by 10 dp like this. Then we can open the lazy list scope and we can then define the different items we want to show. They are coming from our order view model.orderList. We will also pass a key because it's always a good practice to pass a key in such a lazy column, because then if some items would change, the whole list wouldn't be rendered again. It will only switch the changed item. we get access to our order list items here. So we will say order list item, and for the key we pass the order list item .id because this is unique, and I think it's called order ID, and I'm not sure why the compiler doesn't recognize this. Oh, okay, like this we just had to open the lazy lists or the item scope, and in here we will have a order UI list item, and this will be a composable we need to define now. We go to our presentation package in the order feature and create a new package called components. And in this components package, we can create this composable file, which will be order UI list item. And this will be a composable, of course, order UI list item. I've also inserted all the different compose imports because then the typing can happen a little bit faster. Otherwise, there would be always an import necessary for different composables. This order UI list item will take an order list item of type order list item, a modifier which we will set to the default modifier, and the root composable here will be a column. And this column takes the passed modifier. The vertical arrangement will be arrangement.spaced by 10 dp. The horizontal alignment will be alignment.center horizontally. Inside this column we will have a row which also takes a modifier. The modifier here will fill the max width. We also have a vertical alignment, alignment.center vertically, and the horizontal arrangement will be arrangement.space between, so that it pushes the two views inside this row to the left and to the right. This will be on the one hand the deliverer name and on the other hand the total amount. Then we have a text composable which will take our deliverer name, order list item dot deliverer name. The font weight will be font weight dot bold. The color will be white. The font size will be 20 sp. And for the other text we can simply copy this, and let's also import the white color and paste it down here. And for that we need the total amount of the order. We can say %.2f to format this a little bit, dot format, and we say order list item dot total amount, and we will also attach the euro sign here, or maybe you would use the dollar sign, and the rest of the properties remain the same. Then we have a little divider, and the color of this divider will be white. And the last thing is a box, which also takes a modifier. This modifier fills the max width again. The content alignment will be alignment.center. After that we can open the box scope and pass a text into order list item dot order date. The color will be white again. The font size will be 16 sp. And then our order UI list item is defined, and in this order screen we can then import it. For the order list item we simply say it, because it refers to the current order list item. And then we also pass a modifier, and this modifier will fill the max width. We will have a clip for the click effect later, and also for a little bit of rounded corners. Rounded corner shape 10 dp. Then we have a border of 1 dp. The color of this border will be white, and we will also have a rounded corner shape of 10 dp. Then this will be clickable. We will define the click logic later, or well, let's just define it now because we already defined the function for it. In our order view model we defined the on-order click, and we can pass for the order ID it.order ID. And we also have a little padding of 15 dp. Alright, okay, let's actually try this out, if this works so far, if it shows the order item in the right way using this order list UI item composable. We will insert an example order because right now we can't do this in our app. I will show you the example data, but it's a good point now to have a look if actually everything works. Before we start, we need to go to our order feature and create a new package called DI, because we also need a dependency injection module here for our order repository, for example. We will create an object here, and we call this order feature module. We annotate this with add module again, and add install in singleton component double colon class. And first of all, we need to define the provides singleton for our order repository function. Provide order repository. This takes an order DAO, deliverable DAO of type deliverable DAO, and of course for the order DAO we also need to specify the type. And let's put this in separate lines. And also we have the product DAO. This will return an order repository, and it will achieve this by returning an order repository implement. So our concrete implementation, which is behind our order repository interface. We will pass the order DAO, the deliverable DAO, and the product DAO. Dagger Hilt already knows how to provide them because we defined this at the beginning in our core module. Then we can go to our order view model, and I've inserted this example data. Let me also put this in a separate line. This is just an order with one single product, and we can use our order repository to insert this order. So let's quickly run the application the first time, and then we will remove this, and after that we will uncomment this, and we should see this one inserted order. All right, okay, the app launched. This is really good because we already accessing the database and nothing crashed there and everything worked so far. And now we can remove this example data, or maybe uncomment it. Maybe we use this later again. And we uncomment this setup order list and the order initialization. Then we can launch the application again and have a look if the order gets displayed properly. Okay, cool. This looks fine. It lists the order. The order is also clickable, but we don't have the dialog which shows the details of the order yet. Let's implement this now. Back in our order screen at the bottom, we will have an if condition, if order view model dot is order dialog shown, and order view model dot clicked order item is not equal to null. Then we can be sure that we can display this detail clicked order item on the dialog. We first need to define the dialog though. We make this in the presentation components package, and we will create a new package, not a package, composable file. And this will be our order detail dialog. It will be a composable order detail dialog, and I already added all the imports again to make the typing faster. The order detail dialog takes an onDismiss function, which will take nothing and also does not return anything, and an order detail list item of type order detail list item. The root composable will be a dialog composable. It takes an onDismiss request where we can pass our lambda function, which we get provided above. And we also have dialog properties, and we say use platform default width and set this to false, because then we can expand the dialog to the whole width. We will only use 95% for that, but we will be a little bit more flexible. And this is currently in experimental mode, but this is like 2 years now or something like this. I think we can use this here. Then we will open the dialog. We will have a card with an elevation of 5 dp. The shape will be a rounded corner shape of 15 dp, and the card also takes a modifier, which will be modifier.fillMaxWidth to 95%. And we can also set the height like this, fillmax height to 80%, for example. The border will be 1 dp, the color will be orange, and the shape will be rounded corner shape of 15 dp. That we can open the card block, and we will have a column. It takes a modifier, fillmax size in this case, and the padding will be 15 dp. The vertical arrangement will be arrangement.spacebetween. The horizontal alignment will be alignment.center horizontally. In this column we will have another column, and here we have a text. We say ordered from, and then we get access to our deliverable name like this. The font size will be 25 sp. The font weight will be fontweight.bold. Text align will be textalign.start, and the modifier will be modifier.fillMaxWidth. And I think we can then copy and paste this text. This time we will have the order date, which will be a little bit more smaller. We will say order detail list item dot order date. The font size will be 14. We don't have a bold font, and we also want to have a little padding to the top with 5 dp. Then we have a divider which takes a modifier, and this will be modifier.padding to the top equal to 10 dp. After that we have the list of our board products, which will be in a lazy column. For the lazy columns parameters, we say vertical arrangement arrangement.spaced by 15 dp, and it also takes a modifier, and here we say padding top is equal to 15 dp. After that we can open the lazy column scope, and we again have the items, and we will pass the order detail list item dot products. For the key we will use the ID of our product list item like this, and then we will open the block and we will get the lazy item scope. In here we will have a row which takes a modifier. It will fill the max width. The vertical alignment will be alignment.center vertically again. Horizontal arrangement will be arrangement.space between, so the two views or multiple views inside this row get pushed to the side. Then we will have a text, and this text will be our it.selected amount, and we will also attach this little x and plus it.name. So we can see we have 5 times this item, for example. Then we will have another text. We can just copy and paste this. We will just have 2 simple texts here. And here we have a formatted text %.2f, so that we get 2 values after the comma format. And here we say it.price per amount multiplied with it.selected amount. And also we will apply, or we will add a little dollar or euro sign, at the end of this text. Below this lazy list in this column scope, I think this is the right place here, we will have another column where we show the total amount at the bottom with a little divider. We have a vertical arrangement here, arrangement.spaced by 10 dp. Inside here we will have a divider and a row with a modifier. The modifier will fill the max width. We have a vertical alignment again, alignment.center vertically, and the arrangement will be arrangement.space between again to push the elements to the left and to the right. We will open the row scope, then we have a text, total sum. The font weight will be font weight.bold, and I think we can then copy this text and paste it down here. And here we need to apply a little calculation. We will say %.2f because we also want to have 2 decimal places after the comma. We will say format order detail list item dot products dot sum of. So we need to sum all the products selected amounts with the corresponding price per amount. And maybe we should do this in a view model or even in a use case or something like this. I think for the sake of simplicity we can do this in this one line of code. It.selected amount multiplied with it.price per amount. Then we also need to convert this to a double. And after that, at the very end, we will also attach a little euro sign like this. And I think then we can start or invoke this order dialog composable from our order screen. And we can have a look if this is actually working, because we are right now having one order in our database, which we can click on, which we can have a look at the details. Let's invoke the order detail dialog. For the onDismiss function, we will pass the defined function in our view model, order view model dot onDismiss order dialog. And we also need to pass the order detail list item, which we will get from our order view model dot clicked order item, and we can assert that this is not null because we already checked this here above. Alright, okay, let's launch the application and have a look if the dialog works properly and shows the corresponding details. Alright, okay, I already see a mistake. We have €0 here for this order's total costs, but this should be 2 times €1.23, so €2.46. And when we click on this, the dialog opens, so this works, but we have also a total sum of €0, and also no product gets listed. So there's something wrong with the products. I will have to look into this and see you soon. All right, okay, I found a mistake here in our core module inside the entities package. We get the order entity from the database, and it also looks for the product ID with this junction. And we didn't define any products yet. I just inserted the order without defining products. So this will just return two empty lists here. And normally in our application, when the user selects a deliverer and then also products, then there are already products which can then be referred with this ID. But right now we have just inserted an order without any products and any deliverers. So this will just return an empty list. But never mind, the query works fine. It just does not return any products because there aren't any. And we have just an order. Okay, let's implement the next screen, our order choose deliverer screen, where we get a list of deliverers. We can also search for them in a search text field. And then when we click on a deliverer, we get to the next screen where we can select different products of this deliverer. In our order feature, let's also collapse this a little bit to get a little bit of an overview. In our order feature module in the presentation, we will create a new Kotlin file, which will be our order choose deliverer screen. This will be a composable order choose deliverer screen. And this takes a nav controller and also a view model, which we also need to define. But first, let's define the navigation. In our core module in navigation, we will have another composable. This composable will be screen routes.order choose deliverer screen.route, and we will invoke the order choose deliverer screen and pass the nav controller. In our order screen, we can then go up to our floating action button. Here in the onClick method, we will then say nav controller.navigate screen routes.order choose deliverer screen.route, like this. We can also try this out. When we click on this floating action button, then we navigate to another screen. Let's define the view model for this screen. In our presentation layer in the core module, we will create another Kotlin class called order choose deliverer view model. We will annotate this with @Hilt view model again. And we also have dependency injected values here. Add inject constructor. For example, we have the order repository, and we also have two use cases in this view model, but we will first define them and inject them later. Let's have a look at the state first. We will have private late init var deliverers of type list of type deliverer. The same principle here, the deliverers will be our single source of truth, and then we can apply search operations and sorting operations on this deliverer list here. We have a var deliverers to show by mutable state of type list of type deliverer list item, and this will be an empty list by default, and we make this a private set. And first of all, we need to import this mutable state of getter and setter, and we have this deliverer list item, which we also need to define now in our state package. So state package, create a new data class, deliverer list item. Such an item has just the deliverer ID of type string and the name of type string. And then we can go back to our view model and import this deliverer list item. And why do we get an error here? Because of these two brackets. In the init block of this view model, we can then fetch the deliverers. We will again need to inherit from view model to get also the view model scope, of course. View model scope.launch, and we can say deliverers is equal to order repository.get deliverers, and then we can set up deliverers to show. This will be a private function, set up deliverers to show, and in here we will initialize and set up the deliverers depending on the current search query, and we also want to sort them. And for that, we need two additional use cases. But before we define them, let's also define the state variable for the search query. Var deliverer search query by mutable state of, and this is empty by default or an empty string. also of course a private set. Let's define these two use cases in our domain package, because a use case is business logic and belongs to the domain layer. In the domain package, we will create another package called use case, and our first use case will be the filter use case. We will say filter list by name use case. And we make this in a generic way because we have products and we have deliverers, which can both be sorted by their name and also be filtered by their name. We will define this use case as an operator function so that we can later just invoke it like this with these two parentheses. This will be an operator function and takes a generic type T. We also need to say invoke. It takes a list of this type T and also a name, which is our filter criteria. And then it returns a list of type T where T has a specific property or fulfills a specific interface definition. We will define this interface now, and I will explain this after we define this. It will make totally sense. In our core package, in our core module, we will go to domain. We will define an interface which will be called select and sortable by name. And the only thing that this interface requires is a property called name of type string. And then we can go to our deliverer and conform to this interface. So select and sortable by name. And oh, I think this is the wrong place. We need to put it here. And we can then say override value name. And then this deliverer conforms to such a select and sortable by name interface. And the same thing for our product, because we also need this for our product. We will say override value name, and then these two data classes conform or realize this interface. We can close this again, go to our filter by name use case, and now we can say where T conforms or realizes this select and sortable by name interface. Then we can open this, and now we can pass lists into this use case. Let's also put this in a separate file like this. And now we can insert lists in this filter list by name use case. And we don't need to define different use cases for the product and for the deliverer. We can just use this generic use case. We could have also put this generic use case in the core module, I think, because such a use case could be used everywhere in the app. But right now, let's just put it inside our order feature module and make use of it there. In here we can say return list.filter, and we get access to each item. And since each item conforms to this select and sortable by name protocol or interface, we can be sure that this item has a name property of type string. We will also make this a lowercase, and then we ask or we check if it actually contains our past name, which is our filter criteria, dot lowercase. And this is really cool because we can pass any kind of list here which conforms, which realizes this select and sortable by name interface. And this is just the protocol and says, okay, if you are of type of me, then you have a name property, and we can be sure that we have a name here and can filter on this name. The same principle can be applied for our second use case, which is our sort list by name use case. We will create a new Kotlin class inside our use case package called sort list by name use case. This will be also an operator function. The generic type T is defined here. Invoke. It takes a list, and this list is of type generic type T. It returns a list of type T where T realizes the select and sortable by name interface. And here we can simply say return list.sorted by item.name. After that, we need to go to our DI module, the order feature module, to define how such a use case should be provided, because we will inject this inside our view model. We will say add provides add singleton function provides filter list by name use case. This does not take any parameters. It returns a filter list by name use case, and we can simply say return filter list by name use case. We can copy this and apply the same logic for our sort list by name. We will say sort list by name use case. This will return a sort list by name use case, and down here we also need to adjust this to sort list by name use case. Back in our order choose deliverer view model, we can then inject all these use cases. Private val sort list by name use case and private val filter list by name use case. And then we can go to our setup deliverers to show function and can define the deliverers to show. Deliverers to show is equal to filter list by name use case, and we will pass the sort list by name use cases result, and we will pass the deliverers in here and also the deliverer search query. And then we get returned a deliverer, but we need a deliverer list item. So we also need to map this. Here we get access to the deliverer. And in here we need to say deliverer to deliverer list item, but we first need to define this mapping function. But this will be a very short mapping function. We will go to our mapper package and create a new Kotlin file. We will call this deliverer mapper, and this will be an extension function again. Function deliverer dot to deliverer list item returns the deliverer list item, and here we simply say return deliverer list item. We will pass the deliverer ID and the deliverer name. Then we can go back to our view model and import this function, and then the error is gone and we successfully created this setup deliverers to show function. The last function we need in our view model is the onQuery change function. We can say function onQuery, or let's call this onSearch query change, because this can be called from our screen when we detect in our lambda function from the text field a new search query input. We will get a new value of type string. After that, we will say deliverer search query is equal to this new value, and we can invoke the setup deliverers to show function again. And then this gets triggered each time the search query actually changes. Alright, very cool. Now let's go to our order choose deliverer screen. We need the view model here, order choose deliverer view model, which we can get from Hilt view model. In here we need again the scaffold state. Well, scaffold state because we want to show a top bar. Remember scaffold state here. Then our root composable will be of course a scaffold. The scaffold takes the scaffold state. Let's import the scaffold. The top bar will be inside this block. We will have a top app bar, and we only need the parameter list of this top app bar again. We will pass a title, which will be a text. Also import text, deliverer selection like this, and the color will be white, and also the background color here will be set to orange. In the scaffold we will have a column which takes a modifier. This modifier fills the max size. The background will be gray again, and the padding will be 15 dp. Also we have a vertical arrangement, arrangement.spaced by 10 dp. It's also import gray, and the horizontal alignment will be center horizontally. Then we can open the column scope, and first we will have a text field at the top where the user can actually insert search queries for different deliverers. The value will come from our order choose deliverer view model, deliverer search query. And for the onValue change lambda function, we will pass order choose deliverer view model on deliverer search query on search query chain like this. And then we simply pass it. For the colors, we will say colors is equal to text field defaults dot text field colors. We will set the background color to white, the text color to gray, the cursor color to orange, the focus label color also to orange, and the focused indicator color to orange as well. Then we also have a label, which will be a text, search deliverer, and we have a max lines property set to 1. Below our text field, we will have a lazy column with a vertical arrangement of spaced by 10 and a modifier which has a padding of 20 dp. Then we can open the lazy column scope. We have again our items, order choose deliverer view model, deliverers to show. For the key, we have deliverer list item, and we take the deliverer list item dot deliverer ID. And I'm not quite sure why the compiler support is not that good here before we open this. Braces. Okay, all right. Never mind. In here, we will have a deliverer UI list item, which we need to define now. The same principle like we had in our order screen. We will go to components, define a new Kotlin file called deliverer UI list item. And this won't be a class. This will be a composable deliverer UI list item. It takes a deliverer list item and also a modifier, which we will set to the default modifier here. The root composable will be a row, which takes the past modifier, and the horizontal arrangement, let's import row first, will be arrangement.space-between. The vertical alignment will be alignment.center vertically. Then we can open the row scope. We will have a text here, deliverer list item.name. Color will be set to white. Let's also import the different things. And we have an icon, which will be a right arrow icon. We will have an image vector. These imports are annoying. Icons.default.arrow forward iOS. The content description will be arrow right, and the tint will be white as well. Then we can close this, go back, and let's import this. For the list item, we will simply pass it, and then we also need to define the modifier. It will fill the max width. The clip will be a rounded corner shape of 10 dp. Then we have also a border again, 1 dp, color will be white, and this will be a rounded corner shape of 10 dp as well. It will be, of course, clickable. We will define the click logic later because we then navigate to the next screen, and we also need to pass the deliverer ID to get the corresponding products from our database. And we also have a padding 15 dp like this. And I think this should be it for the screen. We can actually launch the application to have a look if everything works fine. For that, let's import some example deliverers. And I've created this deliverer feature because this video is already quite long. And let's just imagine that we have a separate section in our app where we can insert deliverers. And for that, we created this deliverer feature. I've just defined a repository class here and also repository implementation and some mapper function and the corresponding DI module for that. And so we can just use this deliverer function for one-time insertion of example deliverers. We won't need this anymore, but this code is also very cool, this module, if you want to expand the application. But right now you don't need to know what's actually going on inside this deliverer feature. We can go to our order view model, for example, and just quickly insert or inject this deliverer repository. And in here in our view model, we can comment this out. After that, we can say deliverer repository.insert deliverers. Okay, why don't we have this function here? Okay, this is of type order repository. It needs, of course, to be of type deliverer repository. Then we can say insert deliverers and take our dummy data dot deliverers. Then we will launch this one time to insert some initial deliverers. Okay, the app didn't crash, so everything worked fine. Then we will close the app again, remove this, and also remove this injection here. Let's launch the application again and have a look if the deliverers get listed properly. Okay, we don't have orders yet. This is fine. Let's click on this floating action button. And then you can see we have our 3 example deliverers. We can also search for computer, and then you can see the computer deliverer gets shown as the only deliverer which matches the search query. Let's try another word, school stuff. Okay, all right. This works fine, I think. Then we can close the app again, and I think the padding was a little bit too big on the left and on the right of our deliverer items. Let's go to the screen and have a look. We should only make a padding top of 20 dp here inside our lazy column. One last thing I would like to do before we go to the final round, our different product selection screen where we can increase the product amount and also get an overview of the selected products and all that stuff, is to go to our main activity, and in here I will say window.status bar color is equal to orange dot to RGB, and also we will do this for the window dot navigation bar color, orange dot to RGB. Then we get the orange color at the top and at the bottom on the different bars. We can launch the application again to show what I mean by this. Now the bottom bar and the top bar is both orange. All right, okay, back in our order feature module, we will go to the presentation package, and here we will define the last screen, which will be our choose product screen, where we can pass a specific deliverer ID, and then we get a list of the corresponding products this specific deliverer offers. We will call the screen order choose products screen. We can also copy this for the composable definition now. This will be a composable, then we will paste this name. This of course takes a nav controller again, because after we confirmed an order, we will navigate back to our order overview screen. Then it also takes a deliverer ID of type string, which is optional, because when we pass arguments in navigation in Compose, then we are dealing with optional types. And here will be also the view model, which we still need to define. Let's go to our core feature, to our core module. In the presentation package, we will go to the navigation and define the last composable. Here we will say composable screen routes order choose product screen dot route, and we also need to pass a parameter here, so we can say plus, and this parameter will be our deliverer ID. Then we will invoke the order choose product screen. We can pass the nav controller and the deliverer ID. Then for the nav controller, we simply say nav controller, and for the deliverer ID, we can say it, which is a nav backstack entry, dot arguments get string deliverer ID. And this is not sure that this deliverer ID was actually passed, and this is why we get this as an optional, or we need to define this as an optional in our order choose product screen here. Let's go back to our order feature, and in the presentation layer we then start with our view model for the order choose product screen. We will call this view model order choose products view model, and this will be a class. We also need inject annotation here because we need a lot of dependencies in here. We need to annotate this with @Hilt view model, and this time we don't forget to inherit from view model. In here we will have the private val order repository as a dependency, private val filter list by name use case, private val sort list by name use case, because we also want to filter and sort different names, which we will display to the user from the specific deliverer's products. We will have a private late init var for the different products, which will be a list of product, and again we have the single source of truth here with our non-state list of products. Then we also have a private late init var deliverer ID, which will be the deliverer ID we pass into the screen, and in a launched effect we can then set this deliverer ID and start with the initialization. We will have a products to show state var is equal to mutable state list of product list item, and this will be empty by default, and of course a private set again, because we only want to set this inside this order choose products view model. Then we have an additional list which represents our current selected products, var selected products by mutable state of list product list item, and this will be an empty list by default, and also a private set. Let's import the mutable state of the get and set values. The reason why we have a mutable state list of here and here a mutable state of type list is because later we will have a use case where we just exchange or remove one item and add an additional item in our list, and then the mutable state list of will fire in a lazy column, and this mutable state of only fires if the whole list object is actually changed. Then we have a product search query state var by mutable state of, which is empty, an empty string by default, private set, and the last state var is checkout dialog shown by mutable state of false, and of course also private set. Then we have a public function init product list, which we can call from our screen composable in a launched effect where we actually get the deliverer ID, and then we can pass it in here in this init product list function, and we can fetch all the corresponding products to this specific deliverer ID. We will say viewModelScope.launch. The products will be initialized from our order repository .get products for deliverer, and we will pass the deliverer ID. And then we can also say this at order choose products viewModel .deliverer ID is the deliverer ID, so we can save this deliverer ID in case we need it later. And then we invoke setup products to show function, which we will define. But let's first define the on product search query change. We can say fun on product search query change. We will get a new name. This will be called from our screen composable in the lambda function of our text field later. Then we say product search query is equal to new name, and we also call this setup products to show. This will be a private function, setup products to show, and in this case we will have a little bit of a more complicated function because the user can select the product, he can increase and decrease the selection amount, and we somehow want to save the state all the time, even if the user also filters the products and that the product list gets filtered and a new list gets returned. And we want to keep track of the selection of the different products, and therefore we need to apply an additional logic. First, we will have the products to show is equal to filter lists by name use case, and in here we will pass the result of the sort list by name use case, and we will pass the products and the product search query. This time, this was the same principle like we had for our deliverers, and also the mapping function now. We will map such a product to the product list item. So we need to define it. We can say product.to product list item. So this function needs to be defined. In our mapper, we go to product mapper, fun products. This time we don't have the board product because this is a general product. To product list item, and this will return a product list item. Let's also import products. We can say return product list item. For the ID, we will pass the product ID. The name will be the name. The price per amount will be the price per amount. The selected amount will be 0 by default, and also the expanded value will be false by default. Back in our order choose products view model, we can import this, and we still get an error because it requires a snapshot state list. We could say something like this to mutable state list, and the error would be gone, but we also need to add additional logic because we want to save the selection amount state. We will say map again, and this time we will have a product list item, and down here we will have a val selected item is equal to selected products dot first or null. In here we check it.id is equal to product list item.id. This will go through our product list, and for each product list item it actually checks if it's currently in the selected products array. And if this is the case, we can say if selected item is not equal to null, then we know that it is currently selected, and we can return product list item dot copy, and we will say selected amount is equal to selected item dot selected amount. And if this is not the case, then we can just return the product list item itself. And down here we can say to mutable state list, and the error is gone. Now we also need a function which expands the specific product when the user clicks on it, and also collapse it after the user clicks on it again. We will make this a public function because we can invoke this from our composable screen on list item click. This will take the product ID of type string. In here we will need the index of the corresponding product to this specific product ID, and we will define a private function which helps us to determine the index, because we also need the index when we have a plus click and a minus click, and we always have the same logic here: get index of product for a specific product ID of type string, and this will return an integer. We can return product to show dot index of first. We will get access to all the product list items, and we can say product list item dot ID is equal to product ID. Then we can invoke this, get index of product and pass the product ID, and later on we will use this function 2 times, and we will save a little bit of code here by defining a little helper function. Back in our onListItem click function, we will check on the index if it's actually less than 0, just to be sure, because this can return -1 if the product is not found. But this shouldn't happen, because otherwise the user couldn't click on such a list item. But just to be sure, let's check on this index and return if it's less than 0. Then we will say products to show of this index is equal to products to show of this index dot copy. We will set the is expanded var to not is expanded. Products to show of index is expanded, like this. Let's define the logic for the plus click. So if the user clicks on a plus, if the product is currently expanded, and then we want to increase the selection amount by 1. We will call this function on plus click. This takes the product ID of type string, and again we need the index, which we will get from our helper function and get index of product. We will pass the product ID here, and also we will make this little index check. If it's less than 0, then we will simply return. Then we need the current selection amount, which we will get from our products to show of this index dot selected amount. Then we will increase this amount. Products to show of this index is equal to products to show of index dot copy. The selected amount will be our current selection amount plus 1. After that, we also need to update our selected products for the confirm order later for the checkout dialog. We will say if current selected amount is equal to 0, then we know that the product was not selected yet because the selection amount was 0. Then we can say selected products plus equal products to show of our index. And if this is not the case, if the product was already selected, then we also need to update the specific selected product. So we will say selected products is equal to selected products.map. In here we will check if ID is equal to our product ID. Then we will say it.copy, and for the selected amount we will pass it.selected amount plus 1. If this is not the case, we will simply say it. Alright, let's take a little recap at this function. We will get the index first of the specific product which the user clicked on. If this index is less than 0, we will return just to be safe. And then we get the current selection amount because the product which was clicked is in the products to show of this specific index, and this is the property, the selected amount property. We will update the products to show at this specific index by increasing the selected amount by 1. But we also have a list which contains all the selected products, and we also need to update this list. We will check if the current selection amount is equal to 0. Then the product is not selected yet, and we can simply add this to our selected products array. If it's already selected, so if the current selection amount is 1 or higher, then we need to update the selected products array. We will simply say selected products is equal to selected products, and this will each time for each product it will go into this else, and it simply returns it. But one of these products will match this if conditional, and here we simply copy it and increase the selected amount by 1. And maybe you are asking yourself why we have 2 lists here, one for the selected products and one for the products to show. Because for me, we have 2 different states here. We have on the one hand the state of the products which should be currently shown, and we should also have a separate state which represents our selected products. We could also have a products to shown list only, and also an additional property with currently is selected. And down here, or where do we set up the products here, with these 2 use cases, you would also have problems because you get a new list back. And you can try it out and you will see that you will face a little bit of problems here. Then we also need a function for the on minus click if the user decreases the selection amount. Function on minus click for a specific product ID again. We first get the index from our getIndexOfProduct helper function. We will pass the product ID. Again, we make sure that the index is not less than 0. Otherwise, we would return. And then we get the current selection amount is equal to products to show of this index. And here we get the selected amount. And the first thing we want to do is to check on this selection amount if it's actually equal to 0, because we can't decrease it below 0. We will simply return then and just don't do anything. The next thing that can happen is if the current selection amount is equal to 1, because it will decrease then and it will be 0 then, and we also need to remove it from our selected products list. We will say selected products is equal to selected products dot to mutable list, and then we will set apply remove all where its.id is equal to our products to show of this index.id, and then it will remove the selected product, which amount gets decreased from 1 to 0. And the last thing we need to do is to update our products to show. Products to show of index is equal to products to show index.copy again. Selected amount will be equal to our current selection amount minus 1. Okay guys, we almost did it for this view model, and after that we will only have UI logic left. We will go down to the bottom and we will say fung on checkout click. Then we will open our checkout dialog. We will say is checkout dialog shown is equal to true. And we will also have a dismiss function on dismiss checkout dialog. And this will set the is checkout dialog shown state to false. The last function we need here is our onBuy function when the user clicks on the confirm button to actually buy the different products. But for that we need an additional use case. Let's go to our domain package, and in here in the use case package we will create a new class which will be a confirm order use case class. And this use case takes an injected constructor argument, private val order repository. Let's also implement inject. Import, this will be an operator function as well. Invoke, this takes different products of type list, of type bought products. And it also takes a deliverer ID of type string. In here we first need a coroutine scope, which we will get from coroutine scope, and for the dispatcher we will pass dispatchers.io because we will do an input-output operation here. Then we will have a formatter of type datetime formatter, which is equal to datetime formatter.off pattern, day, month, and let's also put this in a separate line so that you can still read this. For the year, we will have this for Ys, then the hour, the minutes, and the seconds. Below this formatter, we will have a date is equal to formatter.format local datetime.now. Then we can say coroutine scope.launch, and first we need the deliverer name. We will have val deliverer name is equal to order repository.get deliverer name by ID. We will pass our deliverer ID, and then we will say order repository dot insert order, and the order will be of course of type order. Let's import this from our domain. The order ID will be uuid.randomuuid.toString. The date will be our date. The deliverer time will be just set to as fast as possible. This is just an example property here, and the deliverer name will be set to our deliverer name, and for the products we simply pass our products, and then this use case is done, and we can go back to our products view model and can define this onBuy function. First we need to access our confirm order use case, which we will also inject via constructor up here, private val confirm order use case, and I'm not sure why this is okay. I've called this use class. Let's rename this to use case, of course, like this, select all, press OK, and then also the property names get updated accordingly. In our DI module, we also need to provide this use case. We can say provide confirm order use case. We will return this confirm order use case, and also down here we make this adjustment. And okay, this also takes the order repository. We can provide it like this. And then we are good to go back to our view model and go down here to our onBuy function. Here we can say confirm order use case selected products.map it.toBought products. And we also need to define this mapper function. This will be the last mapper function we actually need. And for the deliverer ID, we will pass the saved deliverer ID. Let's go to our mapper folder, to our mapper package, to the product mapper, and here we can define this mapping of the bought product or of the product list item to the bought product actually. Again, we define an extension function, this time for the product list item to bought product, and this will of course return a bought product. And we will say return bought product. For the product ID, we will pass the ID, the name will be name, the price per amount will be set to price per amount, and the amount will be the selected amount. Then we can go back and import this functionality, and then the arrow is gone, and we can use this onBuy function. Okay, finally, now we have created this view model and we have finished this view model. And the last thing we need to do is to set up our UI, and then we are good to go. And I think we will need another 20 minutes, and the video is already like 2 hours. Okay. I expected it to take around 1 hour and a half. Well, I think I can do better. Let's go to our order choose products screen. In here we get now access to our order choose product view model, which we will get from Hilt view model. And we first start with a launched effect, where the key will be true, so that this launched effect only gets triggered once on the initial composition. We will say if deliverer ID is not equal to null, because otherwise the caller of this composable didn't pass the deliverer ID. And only if this is not equal to null, we will say order choose products view model dot init product list, and we will pass the deliverer ID. Again, we will have a scaffold state, which we will get from remember scaffold state, and we invoke the scaffold now and pass the scaffold state. Then we will have a top bar again, which will be a top app bar, and like we had on the last screens, we only need the parameter list. For the title, we will pass a text, product, section, and for the color, we will pass white. And let's import this color. Let's also import the text composable. And down here, below this title, we can set the background color to orange. Then we will also have a floating action button, which we can define in this block. Floating action button, this will provide us an onClick function, and we can say order choose products view model dot on checkout click. Then our checkout dialog should open, or at least the state var should be updated to make the opening possible. And down here below this curly braces, we can set the background color to orange. And in this curly braces, we can define the icon which the floating action button should actually contain. We will say icon. For the image vector, we will pass icons.default.price check. The content description will be fab money. The tint will be white. The modifier will be a modifier, and the size will be defined 32 dp. Let's also import dp. And this should be it. Then we can go to this parenthesis and open the scaffold scope. We will start with a column. This column takes a modifier, which fills the max size, sets the background to gray, and also applies a little padding of 15 degrees. The vertical arrangement will be arrangement.spaced by 10 dp. The horizontal alignment will be set to alignment.center horizontally. Now in here we will first start with our text field again, so that we can search for different products. This will be a text field. The value will be our order choose products viewModel.product search query. Then we also have the on value change function, lambda function, order choose products viewModel.on product search query change, and we will pass it. Then we also define the colors, text field defaults dot text field colors. For the background we say white, for the text color we say gray. The cursor color will be orange. I think we would be faster if we copy and paste this from our previous screen, but never mind. The focused label color will be also orange, and the focused indicator color will be orange as well. The label will be of type text, and we say search product, and we also set the max line properties to 1 again. Below this text field we will have a lazy column. The vertical arrangement will be arrangement.spaced by 10dp. The modifier will be set to modifier.padding top is equal to 20dp. Then we can open this lazy column scope. Again we have these items, and we will pass the order choose products viewModel.products to show. For the key we will pass the product list items ID, like this. Like we had in the last screen, we will have a specific UI list item here. We will call this product UI list item, and we first need to define it inside the components here. We will create a new Kotlin file called product UI list item. This will be, of course, a composable product UI list item. This composable takes a product list item. Also, the value is expanded of type Boolean. On plus click, which does not take anything and does not return anything. On minus click, which also is a lambda function and does not take and return anything. And also a modifier, which will be set to the default modifier. For the root composable, we will have a column which takes the modifier. The vertical arrangement will be arrangement.spaced by 10dp. And the horizontal alignment will be alignment.center horizontally. In here we will have a row now, which also takes a modifier, and this will fill the max width. The horizontal arrangement will be arrangement.space between, so that everything what's inside this row gets pushed to the left and the right. And the vertical alignment will be alignment.center vertically. Then we can open the row scope, and in here we will have another column. And this also takes a vertical arrangement, and this arrangement will be spaced by 5dp, and the horizontal alignment will be alignment.start. You will see what these rows and columns are all about in our UI. First of all, we will have the text, which contains our product list item .name. The color of this text will be white. The font weight will be bold. Let's also import white, and then we can copy this text and paste it down here. The second text will be a formatted text. So we will say %.2f.format, and here we say product list item .price per amount. And then we attach the euro sign, remove this font weight .bold, and instead set the font size to 14 sp. So these two texts are basically our product name, and below the price per amount. Below this column we will have an animated visibility, which triggers when the product list item .selected amount is greater than 0. Then we want to show a row with an horizontal arrangement, which will be arrangement.spaced by 5.dp. The vertical alignment will be alignment.center vertically. And in here we will have a check mark and the corresponding selection amount of the selected item. We will have an icon. The image vector will be icons.default.check. The content description will be simply checkmark. The tint will be white. And again we have a text, product list item .selected amount. And we also attach this X here so that we can see that it's x times the selected amount. The color of this text will be white. Below this row scope, we will have another animated visibility, and this triggers if the isExpanded boolean is actually true. Then we will have a divider. The color will be white, and we will have a row which takes a modifier. The modifier will fill the max width. The vertical alignment will be alignment.center vertically. The horizontal arrangement will be arrangement.spaced by 25 dp. Inside this row, we will have our two icon buttons for the plus and for the minus. We will have an icon button. The onClick method will be simply there to invoke our onMinusClick. After that, we can open the icon button's scope, and here we have an icon. The image vector will be icons.default.remove. The content description will be minus. The tint will be white. Then we can copy this icon button, and we also need to invoke this onMinusClick function in here. And here we will invoke the onPlusClick function. For the icon, we have the add, and also the content description will be plus. The tint remains white. All right, okay, then we can close this, go back to our order choose product screen, and import this composable. And for the parameters, we will start with the product list item, which will simply be it. The modifier will be modifier.fillMaxWidth. The clip will be a rounded corner shape with 10 dp. The border will be set to 1 dp. The color will be white, also rounded corner shape, 10 dp. Then this is of course clickable. For the click effect, we will say order choose products view model dot on list item click, and we will pass it.id. And now you can also read it. We will also have a little padding of 10 dp. And below this modifier, we will define the isExpanded property, which will be of it.isExpanded. onMinusClick will be set to order choose products view model dot onMinusClick, and we will pass it.id again. The same thing for onPlusClick, order choose products view model dot onPlusClick, and we will pass it.id. And this should be it for this list. And now it's time to try this out. I will expand this, and let's click on this floating action button and select the computer hardware store. Okay, nothing happens. All right, okay, because the order choose deliverer screen does not have the navigation logic yet. We didn't define this in here in this clickable deliverer UI list item function. Let's close the emulator first. Nav controller dot navigate screen routes dot order choose products screen dot route plus / it dot deliverer ID. And I think, yes, you can see this. We can try this out now. We can start the application. Let's also expand this a little bit so that you can see the floating action button. I will click on plus now and select the computer hardware store. And as you can see, there are our different products. We can also click on them, and then the product expands and shows the minus and plus button. We can also click on them, and then we get this selection information, how much products we actually selected. We can also search for product. Let's search for RAM, and then you can see the selection amount remains. We can also search for something else. For the Intel processor, go back, and then you can still see that our selected items have or keep their state. All right, okay, this looks very good so far. The last thing we need is when we click on this floating action button at the top right, then our checkout dialog should show, and we should press on confirm to actually confirm such an order. All right, okay, let's close all the files above, that things get a little bit more clear and we don't be confused. In our order choose product screen, we need to invoke this dialog, but first we need to define it. In the presentation layer, in our components package, we will create a new Kotlin class called checkout dialog. This will be a file, not a class, a composable checkout dialog. This checkout dialog takes two lambda functions. On the one hand, onDismiss, which does not return anything and also does not take anything. Then the onConfirm lambda function, which also does not take anything and does not return anything. And the selected products we want to show of type list, of type product list item. Then we can start by defining the dialog composable. This dialog composable first takes the onDismiss request, where we simply invoke our onDismiss function. Then it also has dialog properties, which we will use again to make the dialog more flexible, like we had on the other dialog. Dialog properties, the use platform default with will be set to false. And we again need to annotate this with experimental because it's still in the experimental mode. In the dialog, we will have a card. The elevation will be 5 dp. The shape will be rounded corner shape, 15 dp. This card will also take a modifier, fill max width 95% and fill max height 80%. The border will be 1 dp, the color will be orange, the shape will be rounded corner shape 15 dp. Then we can open this scope. First we will have a column, takes a modifier, modifier.fillMaxSize. The padding will be 15 dp. Vertical arrangement will be arrangement.spaceBetween. The horizontal alignment will be alignment.center horizontally. Then we will have another column. This column takes a text. The text will be the checkout text. The font size will be 25 sp. The font weight will be fontweight.bold. The text alignment will be textalign.start, and the modifier will be set to modifier.fillMaxWidth. Below this text we will have a divider, and this takes a modifier as well, modifier.padding 10.dp. Then we will have an if condition, which checks if we have already selected products or if there are no products. Selected products dot is not empty. Then we can show the lazy column and also the two buttons for the confirming and for the dismissing the dialog. This will be a lazy column as the top composable, and the vertical arrangement will be arrangement.spaced by 15 dp. The modifier will be equal to modifier.padding top is equal to 15 dp. Then we can open the lazy column scope, and for the items we will pass the selected products, and the key will be set to product list item .id, and we can open these items and the compiler error is gone. For each product we will have a row item. This takes the modifier modifier.fillMaxWidth. The vertical alignment will be alignment.center vertically. The horizontal arrangement will be arrangement.spaced by. So each selected product name and the price gets pushed to the left and to the right. In this row we will have two simple texts. The first text will be it.selectedAmount times and plus our it.name. The second text will be a formatted text, %.2f.format, price per amount, it.price_per_amount multiplied with it.selectedAmount, and you can still see this. And then we will say plus and attach a euro sign here. In the else case, if we have no products, then we will have a box. Modifier is equal to modifier.fillMaxSize. The content alignment will be alignment.center, and we will display a text to the user. Please select items to order. And since this box fills the max size, it will also go over our buttons later, and you won't see the buttons anymore, but we can also disable them depending on the current selected product's item size. Below this else parentheses, we will take this parentheses, and on the line of this parentheses, we will define another column. The vertical arrangement will be arrangement.spaced by 10.dp. Then we will open the column scope. We will have a divider. This is for the bottom section of our checkout view, of our checkout dialog. The divider won't take any arguments. Then we will have a row. The modifier will be set to modifier.fillMaxWidth. The vertical alignment will be alignment.center vertically. The horizontal arrangement will be arrangement.space between. And then we have a text, total sum. The font weight will be font weight.bold. Then we have another text, which will be a formatted text, %.2f.format, selected products dot sum of it dot selected amount multiplied with it dot price per amount, and then we convert this to double, and at the end we will say plus euro and attach a euro sign. Okay, let's go back here and also define a font weight dot bold. Below this row we will have another row which takes a modifier, and this row fills the max width, of course, and it contains the cancel and the confirmation button. The horizontal arrangement will be arrangement.spaced by 30 dp. The vertical alignment will be alignment.center vertically. Then we can open the row scope and define a button here. This button has an onClick method where we simply invoke our passed onDismiss function. The colors will be set to button defaults dot button colors. For the background color we say orange. The content color will be white. The modifier will be modifier.fillMaxWidth, and the weight will be set to 1f, because on the other button we will also set the weight to 1f, and then they share the space of this row. The shape will be a circle shape. And we also have a text for this button. Text will be cancel. The font weight will be font weight.bold. The text align will be text align.center. Let's copy this button and paste it down below. We just need to update this to onConfirm. And this will be also confirm the text of this button, and the rest remains the same, I think. Now we can go to our order choose product screen and define the logic for showing this dialog, and then we are good to go to actually start the application. And I also think we have finished everything then. If order choose products view model is checkout dialog shown, then we will show the dialog, of course, checkout dialog. Let's also rearrange this a little bit, all those functions and parameters. For the onDismiss function, we will say order choose products view model dot onDismiss checkout dialog. For the onConfirm function, we will of course invoke our order choose products view model dot onBuy. For the selected products, we will pass order choose products view model dot selected products. And we also wanna navigate back to our order view if we trigger an order. So we will also say navcontroller.navigate screen routes .order screen .route, and we will also say pop up to 0 so that the user can't navigate back. Alright, okay, let's try this out, and I hope everything works so far. Let's click on the floating action button, select the computer hardware store. Then we, for example, choose this item, also the 64 GB RAM, and we will have a look at the checkout dialog, and the checkout dialog looks kind of good. And now we will click on the confirm button. And okay, this looks fine. We are back in our order overview. We will see, or we can see, this computer hardware store order. When we click on it, then we also see the different items. And this is a little bit confusing now with this 2 times, but the product's name itself is 2 times 16 GB RAM, for example, and we selected this specific item 2 times. But yeah, I think everything works quite good. We could of course test this further if really everything works, but on the first view, I think this looks fine, and the app is kind of finished so far. Alright, okay, I hope you enjoyed this video and it was not too long, and I also hope that you get more confident now building bigger applications with a lot of data and state logic. And yeah, we will see us in the next video.